the ISO surfaces. So this is an introduction. So ISO surfaces, also known as isometric surface, are a powerful tool in the computer graphics and scientific visualization. This 3D surface represents points of constant value within a dataset, providing a clear visual representation of the complex physical structure. Now let's talk about what is the ISO surfaces. Now you have to look at about that picture, which is uh, this is a picture of IO surfaces that contain a cuboid. Like, now talk about theory. So IO surfaces, also known as the ISO surfaces, are three-dimensional geometric shape that represents points with a constant value within a dataset. They are commonly used in scientific visualization and computer graphics to model and analyze complex phenomena such as molecular structure, temperature distribution, and fluid flow pattern. So this is the application. There are three types of eye surfaces which I have to talk about: medical imaging, computer-aided design, and geographical mapping. So what is medical instruments? Eye surfaces are widely used to medical imaging technique like CT and MRI scans to visualize the internal structure of the human body. It is a very important and very useful eye surfaces. It provide full interface about you can easily and talk about easily watch and scan your body's human body and generate a report by using the IO surfaces. Now, second, computer-aided design is essential for designing visualized complex 3D model and CAD software enable precise control over a surface geometric. And third is geographical mapping. It's very important. IO surfaces are employed and geographical surveys to map and analyze statistical feature, terminus features such as topological contours and surfacial structures. This is a construction of a surface. So like defining the function, first we need defined function like what is scalar field levels at and implicit surface equations, and the second is selecting the ISO value like determine the ISO surface's value functions within the ISO surface will be generated, in which place you want to generate it, you need to define the value. And third is discretization the domain, divide the structural domain into the grid and match the enable to numerical computation, and ISO the ISO surfaces providing the sampling point as a function. Now visualizing ISO surfaces like ISO surfaces is a three-dimensional geometric shape we already talked about in the previous slide, and they represented a point to point and constant value to data with the data sheet. Now this is advantages by using the ISO surfaces, like this is precise representation, seamless integration, flexibility and visualization, computation efficiency. Like this is talk about very this is a good and powerful advantages of ISO surfaces, which is the reason to use ISO surfaces in this current era. Like ISO surfaces offer accurate way to represent the complex 3D shapes, enable detail in modeling and analyzing, and like talk about flexibility in visualization. They are can be easily attended and manipulated, allowing for versatile visualization. And talk about seamless integration and surfaces integrated with the well with the 3D modeling and rendering tools. And talk about the computation efficiency, like the IO surfaces are generally computationally efficient, making them suitable and for real-time applications by using the IO surfaces. It look like realistic. Notice the limitations of iron surfaces versus complexity. Complexity is very high. Data set like talk about generative iron surfaces can be completely intensive, especially for complex data set or a high resolution. Second, I was ambiguity. Talk about ambiguity, like the choice of ISO values can be significant impact the resulting surface, and finding the optimal value is not always straightforward, leading to the potential ambiguity. Third one is topology changes and the noise sensitivity. Topology changes, like we talk about exhibit complex topology changes such as merging, splitting, which can be challenging to be handled the many required specialization. And we talk about the noise sensitivity, like IO surfaces are sensitive to noise, the input data which will can result in artifacts. Know about artifacts? Artifacts is like a byproduct Talk about Now let's talk about algorithms for isosurface generation. First is merging cubes. Second is dual contouring. Third is adaptive match refinement, and third is recasting. Like this is the algorithm which is used in the isosurface generations in the today's generation, and we talk about the interpolation method of isosurfaces like linear interpolation, polymorphic interpolation, radial basis function, spline interpolation. Like what is that? This is a simple method establish value between the data point by drawing a straight line. And polymorphic interpolation is fitting a smooth polymer curve through a plane point. And the radial basis functions using radial symmetric basis functions to interpolate the value to excellent for scattered data handle and complex geometrical work. And we talk about spin interpolations, which is a that join smoothly functions and have to run, and surface equality for many applications. And the last in the future development in ISO surface technology, its first is improve accuracy, advanced and numerical method and computation power will enable to more precise ISO surface generation. Second is hybrid technique, like combining ISO surface with the other visualization technique for enhanced representation of complex data. Third is real-time redundancy, have to improve real-time redundancy input and adaptive refinement. Dynamically exerts the ISO surface solutions to focus on area of interest for improved efficiency. It is used for a human body easy to scan by using this future development of science technologies. Thanks to for all.